Hi, and welcome to Mods. We're keeping you connected to inspiring science with virtual camp discovery brought to you by Citrix, the museum's official innovation partner.
What goes up must come down. Today we'll experiment with gravity to learn what it is and how it works. Feel the gravitational pull into this episode of Virtual Camp Discovery.
Oh hey, welcome back to the channel. Today we're going to talk about what goes up must come down. That's correct, we're going to talk about gravity. Gravity plays a role in pretty much every single thing we do. From social media, to museums, to science class, to us even just getting up in the morning. Every day we know that we're not just going to float off. And the reason for that is because we're being held down by gravity. Not necessarily being held down, we're actually being pulled to the middle of the earth. Luckily, the floor is here to stop us from going all the way there. But what amount of gravity is holding you on the ground right now? 1 atmosphere. There's 1 atmosphere holding us down right now. And I can change that depending on how high I go, or how deep I go, or if I go underwater, or if I'm inside of a container that goes underwater. There's many ways to change gravity around you or use it to your benefit. We're going to do a couple of experiments today that is really going to let you see that. The first one we're going to do is we're going to take this piece of paper right here, regular sheet of paper, and we're going to take this weight, and it's about 4 pounds, 5 pounds, and we're going to drop them at the same exact time. Now, us knowing this, we know that if I drop these at the same exact time, we know that the weight is probably going to hit the ground first, right? So here we go. We're just going to give this a shot. 3, 2, 1. No surprise there. So this one totally hit the ground first before this one. Now why? If gravity is pushing us down at the same exact speed or with the same exact pressure, why wouldn't they hit the ground at the same time? Well, that's because there's other forces at play here. There's wind resistance, which is keeping this up. But if I did want to take wind resistance out of the equation somewhat, how could I physically change this piece of paper to make that possible? Well, I could tear it. No, that's not going to be it. I could burn it, but that's chemically changing it. If I wanted to physically change this, all I have to do is crumble the paper up. And we do this all the time, and then I want to go play basketball, right? And I want to shoot it in the trash, and I miss 99% of the time. But now that we have both of these, this one's smaller now, but if I drop them at the same time, we are changing the wind resistance here. So realistically, they should hit the ground at the same time. 3, 2, 1. We've hit the ground at the same exact time on these. But what if we were to go outside and let's just say we were to drop a ton of bricks off a building and a ton of feathers off a building. We're going to drop them at the same exact time. Which one would hit the ground first? Who says the bricks? Who says the feathers? The answer is they'll hit the ground at the same exact time. Now I know you're asking, well, that doesn't make sense because bricks are solid and tough and kind of like this, but feathers are soft and fluffy. But I did say I have a ton of each. Of course, it's going to take a lot more feathers to make a ton than it is bricks. But because they're both the same weight, they're going to hit the ground at the same time. Now that's taking into account there's no wind resistance on the feathers, so we would probably pack up the feathers really nice and tight so that can't be a factor. Or if you want a really cool thing to check out, go look up feather and bowling ball in a vacuum online. You can check that out later. Really cool video to check out. So gravity plays that role. What about weather? How does gravity play a role in the weather? Well, way up in the atmosphere, water freezes, way up there. And then it starts to do this up and down dance up in the atmosphere. And of course, there's currents that help this go. But when it's falling back down, gravity is playing its role. But as that ice goes up and down and up and down, it's actually turning into larger pieces of ice that we know as hail. And when hail comes down, you really hear it. And hail could be really tiny, it could be up to a quarter size hail, and that's pretty big. A cool thing to do with hail though, once the storm is over, if there's still hail available, go outside, gather up some of the hail and quickly put it individually into the freezer. And then, if you can, with parents' help, cut one of the pieces of hail in half. And actually when you do that, it's kind of like a tree ring, that it has rings. And however many rings it has is actually how many times it has gone up and down in the atmosphere, freezing a new layer on top of the old layer, and then you get to see those rings, which is pretty crazy. Another thing that we want to show you involving gravity is this, and this is a number of necklace beads attached together inside of this container. And we're just going to let gravity do this experiment for us. And the reason for that is, like I said, what goes up must come down. So as this starts to fall down, it is actually going to drag every single one of these with it until they've all emptied out. So here we go. We're going to go in 3, 2, 1, and we're just going to start this coming out. And as you can see, I'm not touching, but gravity is playing its part and pulling that all the way out. So our last experiment, we're going to actually debunk TikTok a little bit here. We have the original TikTok experiment here that you see people trying to do, and we have a bouncy dodgeball, and then we have a tennis ball. And this one's a lot of fun because we're using gravity, and then we're actually transferring all of the energy from this ball into this tennis ball, which is going to get us a cool reaction. So if we drop these, we get a bounce. If I drop this, we get a bounce, right? These are pretty average bounces. But what if I stack one on top of the other, and then I drop this? We're going to see all of the energy transfer from this ball to the tennis ball, and this should skyrocket right off of this ball. So here we go. We're gonna back up a little bit, and we're gonna go in 3, 2, 1. And there it goes. We get that really big bounce from the tennis ball coming off of this blue bouncy ball right here. Well, I hope you enjoyed learning about gravity. I know I had fun showing it to you. We'll see you guys next time. Thank you for joining us for this episode of Virtual Camp Discovery. Special thanks to Citrix, Mod's official innovation partner, for powering this series. Please stay safe and connected with Mods by visiting our social channels at MODSFTL.